Hi folks, this is the 16th problem of the DSA series. It's not actually a problem. Here we'll implement a data structure called Deque or DQ, whatever it is. This is what we'll implement. Okay, so what this Deque is and why we need it. So actually, first let's understand what this Deque is and why we are implementing it, right? So let's take an array, const arr, let's take a random array, like anything, any number can be here. Okay, this is a random array. Now what if we want to add anything in the, like anything at the end of the array? We'll simply use push, right? And the number that we want to add, this is an O of 1 operation, as we know. Okay, now what if we want to remove something from the end of the array? We'll use pop, and this is again O of 1 operation. Now the tricky part comes into picture. What if we have to remove something from the front of the array, that is from the start of the array? So we do AR of the shift, and this is O of n. Why it is O of n? Because it will remove this element, then every other element following this will have to shift one place to the left. That's why O of n. Now what if we want to add an element to the front? Let's say we want to add this element 45. Again, this is an O of n operation. Why O of n operation? Right, because if we add something here, every other element following that have to shift one place to the right. That's why O of n operation. Now DQ is a data structure where all of these four operations are performed in O of 1 time complexity, right? That is, along with adding and removing from the end, the adding and removing to the front is also performed in O of 1 time complexity. Why we need it? While solving DSA problems, no? So yesterday only I was solving some problems around sliding window, and there I felt the need of DQ or Deque. I also didn't know what it was till then. So yeah, we're gonna solve some problems down the line around where Deque is used or is important. So that's why we are learning here what a Deque is, right? And as I told you, there in Python we have this data structure. Python provides this data structure called Deque, where the time complexity is O of 1 for all of these operations, but in JavaScript we don't have any such data structure, so we got to implement it our own. So let's implement this data structure called Deque. So it's a class. Let's write constructor. For constructor, we can have this dot items equals to an object, this dot, let's call it front index. Initially let's make front index at 0, then this dot back index again at 0. Now let's write some functions. What are the functions that we need to write? Obviously, you know, push back. We want to push from the back, right? Again, push front when we push from the front. Then, you know, pop back if you want to pop from the back. Then pop front if we want to pop from the front. Then we can have a function to check if the Deque is empty, so we can have is empty. Then we can have a function to check the size of Deque. Then we can have a function to check what, to let's say clear the Deque, right? So these are, and also write a function to convert this Deque into an array, right? So yeah, don't worry, I'll teach you step by step, and it's very easy, right? Now initially the index, front index and back index both are 0. Now what we gotta write in push back. So for push back, obviously we'll get an item to push the item in the end. So for that, what we'll do is we'll simply say this dot items back index is equals to item. That's it, right? So let's say these are the 3 items. So here back index equals to item, and now let's forget this. Now we gotta do back index, this was back index plus plus, okay, because we already, let's say so this we were at 0, already added an item here. Now if we want to add item in some other time, the back index should be moved to the right, because we already have an item here at 0, so back index should be 1 now, okay. So that's why back index plus plus. Now let's say we want to add an item in the front. Here things will be little different. First we got to do front index minus minus. Why? I'll just tell you why, give me a minute. Then this dot front index equals to item, right, to add an item to the front. So let's say this is 0 0, this is 0 0. Here we already added a back item, and after that we added a back index as well for the next back item that we want to add, right? So this was 0 0. Since we already did a back item, we cannot add a front item here because both front and back index was 0. So we already added a back item here. That's why we gotta do front index minus minus, right? And then add an item there. And here note that this item can be like this as well, like -1 represents some item, represents like some item, then 0 represents some item, and like 1 represents some item, and so on. Like it can be negative, right? This keys can be negative, okay. So yeah, this is how we will push in the front, this is how we'll push in the back. I guess it should be clear. So now how we are gonna pop from the front, okay. So when we pop, how are we gonna pop from the back? So first, in order to pop from the back, first we wanna see if the deck is empty or not. If it is empty, then simply return undefined. If it's not, then we'll pop from the back and return the popped item, right? So first let's write this. If the deck is empty, how we'll check is if it's empty? Obviously if back index is equals to this dot front index, right? If both are 0, obviously deck is empty, right? So this is how we know deck is empty. So in pop back, we'll check if this dot is empty. If yes, this is the case, then simply return undefined. If it's not the case, then do what? Then we gotta remove the last index, right? So for that we'll do delete items this dot back index, this dot, but yeah, obviously we want the item first because we also want to return it. So first we'll get this item and then we will delete it, right? First we'll get this item, delete it, get this item so that we can return it, then we'll delete it. Here one more thing is, as we know that the back index points to the next item, right? For example, like I just show you. Let's say these are 3 items, right? So let's these are 4 items. So this is the last item. So the last item will remain here. Let's say 32, but back index will point here. Okay, so back index will point here. So first, in order to get the item, what we want to do is this dot back index minus minus, so that it comes here. Then we'll have the item as items this dot back index. Then we'll delete this item, okay, and return item. Now this item will be what will be in the picture. This won't be here, and back index will point here, right? Because of back index minus minus. Okay, yeah. Now let's pop front. Pop front will be similar to this. If it's empty, simply return undefined. Now questions asked. Here again the same thing. First we'll check const item is equals to items. Here things are little different, not much different, little different. This dot front index is the item. will delete items this dot front index, and then will return item. Okay, however here what is happening is, let's say this is the thing, this is the front index, this the whatever is here, the front index points here only, not here, right? Front index points here only, so we got to delete it and make front index point here. So first get this item, then delete this item, then point front index to this. So do front index minus minus. So here we got to do later front index minus minus, here we got to do, so no, not actually minus minus, plus front index plus plus. Yeah, back index will be minus minus, front index will be plus plus, right? Okay, so yeah, this is what will happen. So it's easy, right? Because back index points to one item plus one, right? So you'll understand this here better as well. So back index and front index are equal, so back index points to, so let's say this is the thing, and here we have, this is the last item that we have, this is something and this is something, right? So back index will point here, because what if we want to add something here, we'll directly add like this, right? We're gonna add like this, that's why it has to remain empty. And then if we already added something here, then the next back index will point here. Okay, however it's not the case in the front index already points here. What if we want to add something here, then we'll simply first add here, and like add shit here, the front index will point here. Okay, first we do minus minus, then we'll add. First we do minus minus, then we'll add. Okay, so yeah, okay, so is empty is done. Now what's the size? So size is easy, this dot back index kind of length of an array, right, minus this dot front index. Now what if you want to clear all? Simply write this, it will clear. Now what if we want to convert it into an array, this Deque into an array? It's easy as well. Simply have like const arr an empty array, then here simply run a for loop for let item in items, because because items is an object. Okay, an item will give us a key, and then do arr dot push. Although this method is not necessary, like size clear empty, like yeah, for the next problem that we are going to do tomorrow, but yeah, maybe in future we need it, that's why. So here we write items, so that the value will be pushed, and then here you can return arr. Yep, so this is how we implement a Deque. So there's actually one thing that we forgot, not like, although we do push and pop from the back as well as front, we also wanna, what if we wanna see the front element, that is peek in the front, right? Or the back element, that is peek in the back. So we got to write these as well. Okay, so peek front. So what we'll do in peek front, first of all, this will remain as it is. Like if it's shit doesn't exist, return undefined. If it does, simply return the item. What the item will be is, we'll say const item is equals to what, equals to this dot items, and the index can be this dot front index. Yeah, we can return directly here. So yeah, return this. Okay, now yeah, peek back will be the similar, only little difference. First of all, if it's empty, return undefined. If it's not, simply return this dot items and this dot back index -1. Why -1 here? Because you know the back index points to one step further than where the last element is actually present. That's why back index -1. This is the peek back. And yeah, one more thing, we have not returned the size here actually. Okay, so we calculated it, but he have not returned it. Okay, now let's see, everything is fine. Okay, so yeah, we have not used this here. It should be this dot items. Yeah, here as well we have not used this dot items. Let me just search for items. This dot items, this dot items, this dot. Okay, here again we forgot this. Just this dot items. For item in what, man? Item in this dot items. Again, array dot push this dot items. Yep, now it seems complete. Let me quickly go through it if there is something else I'm forgetting. I don't think so. Right? So yeah, now it looks complete. So yeah, you can push an element or pop an element either from the back or from the front using Deque in O of 1 time complexity. Right? Now we'll use Deque in our DSA questions starting the first DSA question tomorrow. Okay, so yeah guys, that's all from my side. Thanks for watching. I'll push this, and yeah, you can see the link in description. Right? Also subscribe to my channel. Yep, bye.